Hey everyone, welcome back to Boyson Crypto Research, where we dive into the world of cryptocurrency and make sense of it all. In our last video, we covered the basics of what cryptocurrency is and how it works. If you haven't watched that, I suggest you check it out. Today, we're going to take things a step further and explore one of the most important aspects of crypto, blockchain technology. So grab a seat and let's dive in. So let's break it down. Blockchain is essentially a digital ledger that records transactions, but unlike traditional ledgers, which are controlled by a central authority like a bank or government, blockchains are decentralized. This means that no single entity controls the data, making it more secure and transparent. Think of it like this. Instead of one person holding the master record, everyone in the network has a copy. This makes it extremely hard to cheat the system because you'd need to alter every copy of the record across thousands of computers. Impossible, right? Blockchain operates using a system of nodes, which are individual computers that validate and store data. When a transaction occurs, it's broadcast to the entire network of nodes, and they work together to verify that the transaction is legitimate. Once verified, the transaction is grouped into a block with other transactions. That block is then added to the chain of previous blocks, hence the name blockchain. Here's something important. Each block in the chain is linked to the one before it through a unique identifier called a hash. This makes it nearly impossible to alter any information without changing the entire chain. If someone wanted to hack the system, they'd need to change every block on every node simultaneously. This is why blockchain is considered so secure. Still a little confused? No worries. Let's use a simple analogy. Imagine a library where every time someone checks out a book, it's recorded in a public ledger. But instead of just one librarian keeping track, every visitor has a copy of the ledger. So if someone tries to alter the record, say they claim they checked out Moby Dick when they really took Pride and Prejudice, every other visitor can cross-check their own ledger and see the lie. That's the essence of blockchain. This decentralized system makes it nearly impossible to falsify or tamper with information, which is why blockchain has gained so much trust, especially in sectors where transparency and security are critical. Now, there are two main types of blockchains, public and private. A public blockchain is completely open, meaning anyone can join and participate in the network. Bitcoin, for example, is a public blockchain. On the other hand, a private blockchain is more like an exclusive club where only authorized members can participate. These are often used by businesses to track internal data, for example in supply chains. So why does this matter? Public blockchains are incredibly transparent and secure, but they can be slower because there are so many nodes involved in verifying transactions. Private blockchains are faster and more efficient for certain use cases, but they're not as transparent because they're controlled by a specific group. Think of it like the difference between the internet, which is open to everyone, and a company's internal intranet, which is only accessible by employees. Have you come across examples of blockchain technology being used in real life, or maybe you're still unsure about how it works? Let me know in the comments. I'd love to hear your thoughts. What's your understanding of blockchain? Drop your thoughts in the comments below and let's discuss it. So why is all of this important? Why are so many people, companies, and even governments getting excited about blockchain? Well, the key reasons are transparency, security, and decentralization. In a world where data breaches and hacking are common, blockchain offers a more secure and reliable way to store and manage data. Every transaction or change is recorded in real time across thousands of computers, and it's nearly impossible to change anything without everyone in the network knowing about it. In sectors like finance, healthcare, and even voting, blockchain could completely change how we manage information and transactions. We're just scratching the surface of its potential.
Now that we know what blockchain is, let's dive a little deeper into how it works. At its core, blockchain technology is all about recording transactions in a secure and decentralized way. But what really happens when you send or receive cryptocurrency, or when any data is added to a blockchain? Let's start with the basics. Someone initiates a transaction. This could be transferring Bitcoin, recording a contract, or tracking a supply chain event. But unlike in traditional systems where a bank or a central authority verifies the transaction, blockchain relies on a network of computers, or nodes, to verify and process the transaction. These nodes are the backbone of the blockchain. Every time a new transaction is initiated, it is broadcast to the entire network. The transaction isn't confirmed until it is verified by multiple nodes, making it secure from any single point of failure. Here's where things get interesting. Blockchain uses various methods, called consensus mechanisms, to ensure that transactions are legitimate. Two of the most common methods are proof of work and proof of stake. In proof of work, used by Bitcoin, nodes, or miners, compete to solve complex mathematical problems. Once a miner solves the problem, they get the right to add a block of transactions to the blockchain and are rewarded with cryptocurrency. This process requires a lot of computational power, which is why people often talk about the energy consumption of Bitcoin mining. On the other hand, proof of stake, used by networks like Ethereum 2.0, selects validators based on the amount of cryptocurrency they hold, or stake, in the system. This method is generally more energy efficient because it doesn't require all nodes to perform complex calculations. Which consensus mechanism do you think is better, proof of work or proof of stake? Or are you new to this concept? Share your thoughts in the comments. Once the transaction is verified by the nodes, it gets grouped with other transactions into a block. This block is like a page in a ledger, but instead of just writing it down, it's secured through cryptography. Each block has a hash, a unique code that identifies it, and also contains the hash of the previous block, linking the entire chain together. This connection between blocks is critical. If someone tried to alter a single transaction, they would need to change the hash of that block, which would break the link to the next block and every block that follows. This makes altering data in a blockchain almost impossible, providing security that traditional systems can't offer. After the block is completed and verified, it is added to the existing blockchain and broadcast to the entire network. This means that every node or participant in the blockchain gets an updated copy of the entire chain. This is why blockchain is often called an immutable ledger. Once a transaction is recorded and a block is added, it's nearly impossible to alter. And because every node has a copy of the chain, everyone can verify that the data is accurate and hasn't been tampered with. Now, you might be wondering, what makes blockchain more secure than traditional systems? The answer lies in its decentralization. In centralized systems like banks, there's only one version of the truth, controlled by a central authority. This makes them vulnerable to hacking, fraud, or errors. In contrast, blockchain has thousands, sometimes even millions of versions of the truth, all synchronized across the network. To hack a blockchain, you'd need to simultaneously alter every copy of the blockchain on every node in the network, a task that is virtually impossible. This is why blockchain is so secure, and why it's gaining traction in sectors that require high levels of trust and transparency. And there's one more piece of the puzzle: cryptography. Each transaction and block is secured using advanced cryptographic algorithms, which make it nearly impossible to decode or reverse engineer. It's like sealing every transaction inside a digital vault that only the authorized parties can open. Cryptography is the reason blockchain is secure and private, even though it's transparent. While everyone can see that a transaction occurred, only the authorized parties can see the details thanks to encryption. Does cryptography and blockchain sound like an exciting topic? Let me know if you'd like a deep dive into how cryptography works in a future episode. That's the step-by-step process of how blockchain works. From verifying transactions to securing data through cryptography, it's a system designed to be both transparent and secure. And as blockchain technology evolves, so do the ways we use it.
What do you think about blockchain's potential? Which industry do you think will benefit the most from this technology? Let me know in the comments. Blockchain isn't just for cryptocurrencies. Its applications are far-reaching. For example, Bitcoin uses blockchain to record transactions without needing a central bank. Ethereum takes it further by allowing developers to create decentralized applications using smart contracts. And companies like IBM are using blockchain to track food from farm to table, ensuring transparency in the supply chain. Of course, blockchain isn't without its challenges. One of the biggest concerns is the energy consumption required by some blockchain networks like Bitcoin. There are also regulatory issues, as governments try to figure out how to regulate a technology that operates across borders. What do you think is the biggest challenge facing blockchain right now? Energy consumption, regulation, or something else? Let's debate in the comments. So what does the future hold for blockchain? Well, we're already seeing early adopters embrace it, but its full potential hasn't been unlocked yet. From decentralized finance to voting systems to digital identity verification, blockchain is poised to transform multiple sectors. As more people and industries adopt the technology, we'll see innovative solutions we can't even imagine yet. Speaking of the future, one area of blockchain that's rapidly gaining attention is decentralized finance, or DeFi. DeFi is reshaping how we borrow, lend, and trade without the need for traditional banks. But we'll save that topic for another video. Are you interested in learning more about DeFi in a future episode? Let me know by leaving a comment below. That's a wrap for today's deep dive into blockchain technology. I hope this video helped you understand how blockchain works and why it's so revolutionary. If you have any questions or thoughts, drop them in the comments. I'd love to hear from you. And don't forget to like, subscribe, and hit the notification bell so you don't miss our next episode where we'll dive into decentralized finance and how it's transforming the financial landscape.